guys and gals. This is going to be the last lesson for our review section for Algebra 2. Now, you may notice that the title of the lesson is a little bit weird. It's 0.8. We were at 0.3. It's because of the book we're using. These are the review sections that I have chosen to work through this year. If you're watching this partly way in the future, or somewhat in the future, I may have decided to hit other review lessons in the future, but for this year, as of recording this video, this is the last one, and that's how I'm doing it. So anyway, there it is. We're going to jump in and do some Pythagorean Theorem. The Pythagorean Theorem, it almost doesn't need to be reviewed because a lot of students tend to remember it really well, but I thought it'd be worthwhile and wouldn't take very much time anyway to go ahead and hit this topic, make sure we know how to do the Pythagorean Theorem, depending on what your past was. So Pythagorean Theorem is a way to find a side of a right triangle. What's a right triangle? Well, it's one with a 90-degree angle. That's what these little pink marks indicate. I am talking, you probably can't hear me very well, but I'm going to roll with it anyway because I haven't started talking about the lesson anyway. So sorry for the weird audio at the beginning. Now you can actually hear me, and I don't sound whatever like I sounded. I don't know. Who knows? But let's take a look at this. So the Pythagorean Theorem is, we're going to do two examples. The Pythagorean Theorem is A squared plus b squared equals c squared, right? So when we're looking at a right triangle, something like this, there are two parts of a right triangle, three really, right? There are three sides, but there are two types of sides. There are these that are adjacent to the 90-degree angle, and those are called the legs. And those are the A and the B. It doesn't matter which one's A and which one's B, just as long as the legs are A and B. And then the third side, the longest side, the one across from the 90-degree angle, as if we draw an arrow through there, it's the one across from it. It is the hypotenuse, and that is always the C. It's always the one by itself. So without further ado, let's jump in and look at a couple examples. So we've got a couple of different types of examples here. And the first one, we have two legs. So we're going to use the same formula. So we're going to plug in where the legs are. We're going to plug in these numbers. And then for this one outside, we're going to, the hypotenuse, we're going to plug in just c squared. Now, that is very important, and if you're going to make a mistake on a Pythagorean Theorem problem, it will be forgetting the squared on whatever the variable is, wherever the variable is, and forgetting to deal with it at the very end. We'll see that here in just a second. So when we take and we plug these numbers, we're going to put a 6 right here and a 10 right here, and then we just work on doing the math and finding c. So 6 squared is 36. 10 squared is 100. And then we've got c squared. And then we do 36 plus 100. And we get 136 equals c squared. Now, we need to get rid of that squared. We don't want that squared to be on there, so we need to take care of and get rid of it. So what's the opposite of squaring? What is the opposite of squaring something? Well, it is square rooting. Or if you're in Europe somewhere, then you would call it unsquare, right? And I wish we would call it that in the United States. It makes way more sense than square root. What does that even mean? Anyway, all that to say, we're going to take the square root. Now, it's worth, and I'm not going to even write this down, but it is worth noting for the future and kind of having in the back of your brain, because we're going to see this later when we talk about quadratics and other things like that, that whenever we take the square root of both sides of an equation, then you end up with plus or minus that thing. Now, we're talking about distance, and distance is only positive, so we're gonna throw out the negative one in this case. And again, I'm not even gonna write it down yet because I don't want to confuse you at this point in the course. But that's something to keep in mind and kind of keep in the back of your mind. When we take the square root of both sides, we end up with plus or minus. just log it in the back of that brain somewhere, right? Okay, so our answer is C equals the square root of 136. Now, we could potentially simplify this square root, but we can just circle that. Now, you could also get the decimal equivalent. Let me pull up my calculator real quick. All right, so we could also get the decimal equivalent, and we would write that as C is approximately equal to, and we'll plug that in the calculator. We'll do the square root. On this particular calculator, we have to use shift and then the square root button. Your calculator, the square root button will be different. It'll be somewhere else. If you're getting one of the calculators that I recommend, then you will put the square root button first and then the number. If you're not using a calculator that I recommend, you might, depending on the calculator, have to put the number and then the square root. But if you're using any of the calculators that I recommend, you'll hit the square root button and then whatever you're going to take the square root of. So we're going to do square root of 136, and we get 11.6619, etc. We get a non-repeating, non-ending decimal, an irrational number. We're going to go ahead and round this to the hundredths place. The problem will probably tell you, if you're in my class and the problem doesn't tell you where to round, my standard is the hundredths place, which is 2 places after the decimal, right? So that's how you usually round in my class. So we forgot to write the units here. So this is feet. This is, what did I just get? 11.66 feet. All right. So either at this point in your math career in my class, as long as we are, unless we're talking about a word problem, either one of these answers is completely fine. Now, once we learn how to simplify a radical, we'll want to do it in that format. We'll want to make it exact and all those things, but we'll talk about that later in this class, right? So let's do this second example. So this time we are given the hypotenuse and we are given a leg. So we're going to, instead, we're going to plug in a squared here. So we're going to put the variable over here and then plus, and then we're going to make places for where our variables are going to go. So the one by itself is this 25. That's the hypotenuse, the one across from the 90-degree angle, the longest side of the triangle, right? So we're going to put 25 in there. So one of the 2 legs, we could, now we're given A, so I just wrote it in the place of A. But again, it doesn't matter which leg is which. It's going to be the same way mathematically, right? So we're going to put our 7 right here. Excuse me. So we're going to just kind of do the math. We're going to bring down A squared plus 7 squared, which is 49, equals 25 squared, which, unless I'm greatly mistaken, is 625. I don't know. Having a bit of a brain fart. I think it's 625. Let's find out. 25 squared is 625. I was right. I don't know. I was afraid to write something wrong right there, right? I like to, I commented on this in the last video. Generally, I like to not reference my notes and just kind of hand you the answer that way, because I feel like that's much more useful to you to be able to see kind of the working out and the scratch work and the thinking through things and all of those pieces, so that it's more like what it's going to be like when you actually go to solve these problems. So we got to finish solving for A. We're not done here, right? So we got to get rid of this 49. How is the 49 attached to the A? Well, it's added. So we do the opposite or the inverse to get rid of it. So we're going to subtract 49 from both sides. Minus 49 minus 49 cancels on this side. So we've got A squared equals 625 minus 49. I can just put minus 49. All your calculators, if you use one of my recommendations, have this little answer thing on there. So 576. How do we get rid of this squared? We square root it. Remember that in the future, well, even now, when we're not talking about a distance or something like that, we're actually getting a plus or a minus. But for now, we're going to throw out the minus because we're talking about distance. So A equals the square root of 576. I think this one actually comes out even. So I mentioned, and you may know this about your calculator, I like to point out calculator things when I can, and especially in these early lessons. So most of your calculators, if you use any of the ones that I recommend, you're going to have an ANS or an answer thing. And what that is, a variable in your calculator that holds the very last number. So whatever the very last answer was, it holds it. So we can use that in this case to just, in this case, I hit shift. Now yours may have second or whatever else, depending on what you're going to use. So I'm going to hit shift and then I'm going to hit square root. And then if I hit shift again and answer, it's going to take and put A and S, which is at 576, right? So then I hit enter, and sure enough, I was right. Now, that was in my notes, so I kind of cheated a little bit on there. But our answer is A equals 24. Don't forget to put the units when we have them. It's 24 centimeters. Okay. And that is it for Pythagorean Theorem. That is it for our review chapter or unit or whatever you want to call it. I will see you guys in the next one. Have a great, grand, and glorious day. Bye-bye.